Hello, hello. Welcome to another edition of Live Code Tuesdays, our weekly stream about things in the world of WebAssembly. My name is Sohan Maheshwar. I'm coming to you from a very, very windy Amsterdam today. You can see the trees just swaying in the wind right next to me. And we have a special guest with us today. We have Kingdon from Flux CD, and we are going to be speaking about SpinKube and Flux CD automated on Kubernetes. So just a bit of a background. We've been planning this demo for a while. Kingdon has some very cool stuff to show us today. Kingdon, over to you.
Thank you. Nice to be here with everyone. I'm not sure how many people are on the stream right now, but we'll see more people filter in eventually. We're going to show off Flux and SpinKube. I'm Kingdon. I'm a Flux maintainer. I also have this great shirt, so you know. You may have met me at KubeCon. If you've been at KubeCon, I usually hang out by the Flux booth. I've got a nice demo here. We're using a couple of different technology things that I'm just trying out. So there's Cozy Stack that runs on Talos Linux. So we have an immutable base OS, and there's also KubeVirt. If you don't know about Cozy Stack, it's got everything you need to run virtual clusters that are based on virtual machines, which we need because we need access to our nodes. So we can't really do much with a Talos unless we use extensions. We'll get into all that as we pull up the README, but I've got a few links to share here.
Yeah, for folks joining in, let us know where you're joining us from. Kingdom, where are you based again? In the US, I assume. Central
I'm
US,
in South Bend, Indiana. Yeah, I'm in the Midwest.
Nice. Okay, awesome. Yeah, the cool thing about doing, I think, CI/CD demos, at least CD demos, is if something goes wrong, maybe that was the point of the demo. So if something goes wrong today, things should automatically sort of work its way back up.
Yeah, I will say there are a few things that are planned and scripted to go wrong, but I'm not going to tell you which ones they are.
Okay. No spoilers. Cool. While Kingdon brings up the README, I will also bring up the screen. Yeah, there we go.
Oh, it's telling me I can't post a comment. Maybe.
Yeah, you just send it on the private chat and I can post that perhaps. We have, someone from Lithuania. That's awesome.
Josas is a long friend of mine. He worked with me at Weaveworks.
Oh, excellent.
And
well,
actually,
thanks for joining in.
Already some of Josas' software is on the screen.
Excellent. All right. We have Peter as well. Good day from Idaho. Well, thanks so much for joining in, Peter. For folks joining in for the first time, we do this stream every week. We talk about things in the world of WebAssembly and things that are related. Of course, today we are demoing SpinKube and Flux CD. So yeah, thanks for joining in. I'm going to send this link onto the chat so that y'all can see it. And I will also post it up here. Kingdon, over to you.
So this repo is based on an example from the Flux docs, and we might go and look at the Flux docs a couple of times throughout here so we can see where this is based on. But this is a good example of using Flux to use Customize and Helm to orchestrate deployment. So if you're not familiar with any of this mumbo jumbo, of course, GitOps is for putting your workloads on Kubernetes, and you store them in Git. That's the start, but there's a little bit more to it than that. All right, sometimes you have a Helm chart, and there's Customize that I will not belabor right now because it's an unimportant detail. But so the good news is you don't need all of this Cozy Stack mumbo jumbo in order to try. You can use K3D if you want. So you can try all this, and what we're going to do, there's a lot of different resources here that are all Flux resources. I have a pre-staged commit so that we can suspend them all. And what we're going to do, after we've seen that everything worked at least once, because it's all running right now, we're going to tear the entire cluster down. We're going to stand it back up. We're going to bootstrap, and we're going to step through so we see exactly what it is that we did.
And hopefully all of this in an hour or so, right?
Yeah.
Cool. So let's get to it. Before that, quick shout out to Fly from Amsterdam. Hey, Fly. And also Will Christensen from Philadelphia. Thanks, folks, for joining in. Again, if this is the first time you're joining the stream, we do this at the same time every Tuesday about stuff in the WebAssembly world. Yes, Kingdon, over to you.
So We've got port forward as an example. So what we're going to do first, we're going to use a UI that's called capacitor. If you've seen me demo with Weave GitOps before, Weave GitOps is still out there. I'm using capacitor today because there are actual active maintainers for capacitor. And right now, Weave GitOps is open source, but only in the free as in beer sense of the word, and also free license. Uses Apache, but there's no one actually actively maintaining it anymore. If you're not aware, Weaveworks closed down at the first of the year. So that was sad for all of us. But so capacitor is a new UI that's a little bit lighter weight. It has less goals than Weave GitOps. I'm showing it to you now also because once we get going, when we tear the cluster down, there's a bit of a bug in capacitor. This is pre-release software. A lot of the stuff we're going to see is actually pre-release or in some sort of limbo state, like the VS Code extension. There's no one who's being paid to maintain it right now. So, and actually, we've been at a bit of an adversarial state with Microsoft, because when we released a new feature that you're going to see that allows this to smoothly refresh, at about the same time, VS Code released a new, I'm sure they're not aware of us that we did this, but we were using some private APIs that they moved, and we learned that we shouldn't have done that. So if you know the exact combination of VS Code and our extension, you can get this smooth feature. Otherwise, you'll have to push the refresh button a little bit. But so let's see spin app running first, since we're going to. All right. So this is our spin app, and if we refresh, this is just the simple spin app. The Rust Go, I'm not sure which one it is actually. It has Go, Hello. I think it's multiple different modules bundled together. So there's also Hello, and this is Hello in Rust. Mm-hmm. And if you've set up spin demos before, you've seen that. So this is running on our cluster, and it's running through one of these. I think it is this one. Default. Yeah, here is simple spin app. So we can pull this up in the UI and see what a spin app looks like when it's installed in the cluster. It's got some extra garbage that every Kubernetes resource gets, and the status. So we can see the status. See ready replicas 1. So we see it's serving. And there are a few other resources that we can't see because they're created by the spin app, the deployment, the service, but they are there. We could look at them with Kubernetes if we want to see. So there's our simple spin app service, and there's also happens to be an ingress here that we have an ingress controller and a load balancer to enact. You won't be able to do all of this, I think, if you're using K3D, but it's all here. We're going to tear it all down, and hopefully it all comes back exactly like it is as we step through. So really fingers crossed. A lot of stuff went wrong when I did this yesterday, so it's going to be a miracle, but it all worked this morning. So,
so we got the bad juju out of the way yesterday. So
yeah.
This
is also a pre-release of Cozy Stack, by the way. I had problems on earlier versions of Cozy Stack. They've been very responsive to help me work through the problems. I think Cozy Stack is a very new project. It's based on Talos, which is a much more mature project. But if you noticed, I mentioned here some things about different cluster requirements. So if you're using a cluster where you have access to nodes, this is the one thing where you'll have to do something a little bit differently. And there's just a stop where I'm unpausing something, and you'll see you just won't unpause KWASM operator. You'll leave that one out. Or if you do unpause it, it won't do anything. It's fine. So, but if you're installing directly on Talos Linux, there is a way, if you know how KWASM operator works, and I guess Runtime Class Manager is the new version of KWASM operator that's in the works. If you know how it works, it gains privileged access to the node, and it copies a binary to the host file system, and it sets up containerd so that it knows how to find that binary. And I'm not exactly sure of the difference between KWASM operator and Runtime Class Manager, but my understanding is they both principally do this. So if you're running a system like Talos with an immutable base file system, that's just not going to work. And And so you need a different way. And Talos, the different way they have is called a system extension, which there happens to be a system extension for Spin that's also very new. So you can try either of those, or you can use K3D. There is a K3D image that comes with a Spin shim already pre-installed, and I think that's the easiest way to go if you're trying this demo at home. And let's get to it. Let's start deleting stuff. Let's see if it comes back when we want. So before we delete everything, we're going to see the structure of Flux and how Flux applies stuff to the cluster. Old Flux was monolithic, so it would apply everything all at once, and it was like fire and forget. If you wanted to see what went wrong, you had to go read through logs because that was how the old Flux worked. New Flux is cloud native, and it uses CRDs. So each Flux applier, this is called a customization. There's two applier types in Flux, customization and Helm release. And they both pull from a source type that handles all of the details around fetching the artifact and verifying provenance, and anything else that's related to sources basically gets handled by the source controller, and the customized controller handles this other customized resource. So usually what you do is you use customization to apply resources like Helm release, which then will activate the other applier, and they'll pull from their own source kinds. That might be OCI repository or Git repository or Helm repository. Those are all possibilities. And in fact, Cozy Stack does something a little bit different. Cozy Stack doesn't have a Git bootstrap. So what we're going to see is actually Flux Bootstrap. This is the recommended canonical way to install Flux. So if you've used Flux and you've never done this, which there is actually a decent possibility now because of all the infrastructure vendors out there that offer managed Flux, like Cozy Stack and Microsoft and VMware, I think. There are a lot of those distributions out there, and they don't always teach Flux best practices from the get-go. So that's what we're going to try to do today. We've set up a system so we can bootstrap, and we'll see. It's got a lot of pods on it. Here are all of our pods. This is actually a relatively small number of pods because we have a test cluster for this. So we're going to go to the Talos metal cluster that runs Cozy Stack. See that it has actually no customizations at all. KG, this is an alias here. It's kubectl all namespaces. Okay, so
we've had this running joke, Kingdon, for our last few streams where we're trying to see if people don't use K as an alias for kubectl, and if there's anyone in the audience who just prefers typing kubectl out, let us know. But
yeah, when I practice a demo 100 times, I really don't want to type any more than I have to. So.
There are a couple of questions, Kingdon,
sure.
if you don't mind asking.
Yeah.
So one is, and Bill, thanks for clarifying as well, but I'd love to hear Kingdon's thoughts on it. Is Flux CD and Argo CD competitive, right? And instead of, maybe I could rephrase this question from K, which is maybe what are the differences between like a Flux CD and an Argo CD?
Yeah, I would like to address the question as it's asked too, because this is a good question. And I think competition is important. I think that's one of the things that makes an ecosystem healthy is when you can see there are more than one viable option. So I would say, yes, there definitely is a competitive aspect between them, but no, not in the sense that you mean. We're not in business, so we're an open source project at this point. So let me see. So we have a dashboard. Cozy Stack is made by a company, right? For example, it's actually 8,000, right? The company is called Anix, and I need this token here in order to access the dashboard here. Sorry, I have to grab the token. I think it is that one. Here, screenshot that real quick if you want. That's not.
Everyone, look away quickly.
Yeah,
look away.
So this is the Cozy Stack dashboard, and this is very ClickOps. And this is one of the ways that I'll highlight that explains how Flux and Argo are different. Is that Flux treats Git as a single source of truth, and Flux Bootstrap is a core concept in Flux. Argo has something like Bootstrap, but it's not as much a core concept. So this is a Kubernetes cluster here that was deployed by clicks, and we're going to delete it by click. And this is horrifying if you're a GitOps person like me, but it's doing Helm release under the hood. So I really wanted to know about Cozy Stack because it uses Flux, and I wanted to be able to review it and say if it's any good. And so we're deleting stuff right now, and it's going to take a second. There, the cluster's gone. So you can see some things are terminating here. Their virtual machine launcher. All right, we're going to put that back now. But it's just a generic cluster. We're not putting back any of the workloads. So when it comes up, it's going to be missing everything, including, I think, CNI, or it'll have CNI, but that's it. So it's named test, and it has a public control plane endpoint. There's another trick that I've done we're not going to look at in order to make that public with my one home IP address, but I'm using traffic.
Nice.
Combination of traffic and Nginx ingress on several different levels. I actually have an architecture diagram if we have time. We'll get back to that, but you have to see it work first.
Yeah.
All right, cluster's coming up. That error is okay. That's the autoscaler. It's going to error out until we have some nodes. And the nodes have to spin a couple of times because they have a, I think it's called CDI for a container. I don't know what that stands for, but it's the system that delivers the initial file system to the virtual machine. So Cozy Stack is like a fully provisioned cloud provider. It's designed to help you build a full pass that you could even resell. It's got billing hooks in there, so you can see how much each tenant is using and bill them appropriately.
I just looked it up. It's containerized data importer.
Data importer. Thank you. Importer. That's okay. Exactly what it's. Yeah, it does what it sounds like.
Yeah. There's a question from Peter, which I think I can take, but I need a clarification. Peter, when you say, does this work with the Fermion cloud service that I'm planning on using? Can you specify what you're referring to with this part? I mean, just so that I can answer your question better. And then, yeah, we can let you know. Also, shout out to Will in the chat for some answers as well. Yeah, Flux CD is a CNCF graduated project. So, that's maybe one difference as well between Flux and Argo.
Yes. Funny story. Flux and Argo graduated on almost the same day.
Okay. Nice.
There was definitely, in terms of competitive aspect, there was definitely a goal to be first. And when it was down to like one day or the other, I'll just tell you that Flux was first. But it doesn't matter. Obviously, it doesn't matter. But Flux was first.
Okay.
Yeah. We're good friends with all the people at Argo CD, and I think there's even some cross-pollination now between the companies. Now that Weaveworks is gone, some Flux folks have gone to work for Argo companies. At least one person. I don't know. I won't say folks. I don't want to point anyone out, but
got it. Yeah. Will is basically saying this tech stack is like drinking from a fire hose at the start. You'll get it under control soon, though, so don't give up.
Yeah. So there's one thing I'm going to do here manually besides that click. I'm going to delete this load balancer because we want that IP. And if we don't delete this one, it's going to be in use when we come back here. Okay, so one more thing. We are going to get our kube config for our test cluster. And we're going to delete the old one. Okay, and now we can actually switch with the UI. So we can see what's running on the cluster. It won't be much. Actually, it won't be anything at this point from this UI's perspective because this UI only looks through the lens of Flux. So when people try to conceptualize GitOps who haven't used it for the first time, there are a lot of preconceptions that have to be dispelled. And one of them is that Flux has to manage everything on the cluster. So we'll see that Flux is not installed on this cluster. And it's got a few things on it already, and these things will not get managed by Flux at any point. So right off the bat, that's false. You can definitely have things on the cluster that are not managed by Flux. You don't have to manage everything. So it looks like the cluster came up, and we're able to reach it through the other load balancer. So let's bootstrap now.
Yeah. Okay. So Peter's okay. Peter, I don't know if you have stepped away, but I'll put the answer in the chat in any case. So this demo won't work on like Fermion Cloud, because the Fermion Cloud is essentially for spin apps. This would work on like a Kubernetes cluster, which is what Kingdon is showing. This uses something called SpinKube, if you haven't checked it out, which is a way basically to run and operate WebAssembly workloads within Kubernetes. So check out spinkube.dev. I'll put the same thing in the chat so that you can get to it later as well. So, yeah.
I'm going to make this a little bigger.
Yeah. Hey, naughty Sean. Kingdon Flux wasn't so much good in the room. Going to try this on Sivo Cloud after work. Awesome. Well, thanks, Sean, for watching the stream and joining us.
Cool. This should work on any cluster that has you as the user at this point should take this repo and fork it, and then try the exact same steps from this point. So if you have any cluster, you should be able to repeat this as long as you have access to the nodes. If you have a different type of cluster, there are different options, but feel free to ask questions. So what's happening right now is a few things. Bootstrap is arranging a deploy key for us so that we have read-only access to this repo. You need a personal access token that has admin rights for the repo in order to do this. So the admin token is not stored on the cluster. An SSH key is generated right on the cluster. It's only ever stored there. And the public key gets copied as a read-only thing. So part of GitOps is it should be read-only, so that it can be pull access. If there's anything that needs to push, oh, we got a thumbs up. Thanks, macOS. All right, so that worked. And before we miss it, we need to start watching what's happening on the cluster. So I'm not going to pull up capacitor at this point because it's got a bug, like I mentioned, that if, but everything is already off to the races here. So, I forgot to pause things before we started. So we can watch it and talk about things, but it's going to go quickly, which is probably better. We'd like to see the result rather than talk about each step. But what's happening here, I've created numbers for these so that it's a little bit easier to see and that they're formatted in order. The numbers don't do anything functionally other than for formatting. The way that these things are organized, see, this one says dependency not ready. I'm not sure if you can read that, but dependency not ready means there has been a dependency arranged for us. So we can click on that and see what does that definition look like in Flux terms. It says depends on infra controllers. So we're waiting for infra controllers to be ready, which it just has become ready. So now we can see this one is progressing. And when you bootstrap, you will also see that things take a little bit longer than this. I have reduced one of the wait times for dependencies so that we don't have so long of a wait. There's one thing that is going to be wrong, I think, and I've done it now. I gave it away, but well, no, we don't know. We're just going to go along. We're going to look and see if we find anything wrong. All right, so got a few things. Container creating. And we see this one has an error. Failed to create pod sandbox. Failed to get sandbox runtime. No runtime for spin is configured. So if we step through all of these things, one of the things is a set of configs, here, infra configs. And we've actually got some nodes defined. I don't know if we can see them in here, but oh yeah, 2 nodes. So that Flux can actually patch the nodes for us. If you've been through the spin steps before, the SpinKube steps, for KWASM operator, one of the steps is the nodes that you want spin apps to run on need to be annotated a particular way. So they get the special treatment that we mentioned before. And these are actually not the nodes that we have now because we've just restarted the entire cluster. Spin Tuesday demo, that's where we have this stuff. So we want to do git pull because we've just bootstrapped and that might have created a new commit. And we've got infrastructure configs. Let's look at a tree of this when we come back, when we've got, so we can see exactly what files are in here. But here we've got 2 nodes defined. I wonder if it's actually going to create nodes for us here, or if those nodes are going to be. Flux applied these YAMLs rather than patching something because there was nothing there with that name to patch. So, but if we look at the node YAMLs, we have an annotation here that says SSA merge. So the goal of this is actually, we don't ever want to delete a node this way. If this config should ever be removed, we would like to keep the node rather than delete it. This is meant to merge this annotation in. So we'll get this KWASM node true, and it will go ahead and apply the necessary things. Did I just, yeah. I think that was the right one. Yes, and then the other one is there. So I'm going to kick this a little bit to make it go faster because there's one other thing I haven't set up here. Oh, it looks like it's already moving. There's a receiver in Flux that's a webhook receiver, and you can set it up so that when you push a commit, Flux receives that commit right away. For demos, it's particularly helpful, but you can also just set the timing very short if you're not worried about that. Okay, so we've got some container creating happening now. Let's see if we can catch the logs here. See what it's doing. Oh, it's in KWASM namespace. Can we see what it did? Does it tell us? Oh, it's got an error. That's interesting. But we got 2 completed without error. That's what we wanted to see. And we should start to see that default. It's running. It's running. So all the moving parts are in place, including ingress. So there's one other thing we're going to change here before we pull it up. We've got ingress configured with cert manager. So we actually got a certificate. But this is a staging certificate. So if we go to simple here, we're going to get cert authority invalid. And I did that because I was testing this a bunch of times, and every time I tear it on the cluster, there's a risk that I'm going to get to the cert manager rate limit, the Let's Encrypt rate limit. But this is a certificate. And if we just change a little bit of config, we can get a production certificate. Why don't we go and edit this in the editor, where it'll be a little bit more visible for people. Maybe easier for me, too.
I see some folks have just joined in. Sorry, Kingdon. Yeah. Again, just a quick recap of what we're doing. If you're new to the stream, this is Live Code Tuesdays. My name is Sohan. I'm a dev advocate at Fermion. We do this every week at this time, where we do a live stream about something in the world of WebAssembly. And today, Kingdon is showing us how to use SpinKube and Flux CD, all on Kubernetes. If you haven't seen or worked on SpinKube before, there are a bunch of videos that we've done earlier. Essentially allows you to host WebAssembly server-side apps in like a Kubernetes cluster. And yeah, Kingdon's essentially, he's turned the infrastructure down. We've got it back up now. And we are, I think, changing the certificate for a production cluster. Okay. Yeah.
So yeah, we've got a new issuer here, we're going to delete the certificate that's in place. We're going to delete the secret. And we see it creates another one right away. And now it's actually ready already. That's surprising. Oh, you know what? I don't think there was enough time there for it to apply all that config. Did we actually push that config and commit it? We didn't actually push it. Okay. So that's GitOps error number 1 there. You got to make sure you push your commits.
Yeah.
And
what does Flux reconcile source do, Kingdon?
It puts an annotation on the Git repository to tell it to reconcile right away. This is the same as right-clicking on it in the UI and saying reconcile. And there's one further thing. If you are on one of these workloads instead of source, so workloads all subscribe to their source in Kubernetes. So when the source gets a new commit, it gets applied by the workload automatically. You don't have to arrange that. The only thing you want to arrange is that when the source actually gets a commit externally, you create a receiver that has another ingress. So there's a couple of ingresses on this cluster so that we can arrange such a thing. I haven't set that up today because, as you've seen, we've just torn the whole cluster down and set it back up. I haven't added any secrets. You can use Flux to manage encrypted secrets, which we're not doing here yet. But if we were, we would put our webhook in that secret, and then it would be restored with the cluster. It's kind of hard to do that in a home lab environment because you really need something like IAM and what do you call the KMS to store secrets in an external way. So where we look at my architecture, you'll see I have this problem where this cluster depends on some services to be already in the network. Otherwise, I can't have multiple clusters that all have a public endpoint. There's a bit of config I haven't shown you that's the behind the curtain stuff, but
got it.
So let's delete that cert again and the secret. And this one should take a few seconds because it actually has to do the challenge.
Yeah, Will says Keycloak. That's the best DIY home lab secrets management I can think of. Have you used that, Kingdon?
I did use Keycloak once upon a time. Yeah. Yes. It was big and complicated for me. I've downscaled to Dex now is what I'm using. So this cluster doesn't have Dex enabled, but Dex, I'm using Dex for the parent cluster. So so that I can get access without copying a kube config out. So I use GitHub OIDC to authenticate, and then I just have to have a cluster admin role that's tied to that GitHub OIDC. So the challenge is gone, so that's good. That means the certificate probably is okay. And now you should be able to visit our Spin app and not get that error message here. Let's draw in a new tab. Yay! Nice. We have a good certificate. Okay, so all that stuff was fun, and we can look at the capacitor UI again now because it will be working. The bug is actually if things have not all reconciled. I haven't figured out how to fix this because I'm not a React developer and I have low aspirations on that side. But somewhere in capacitor 0.4.2, there is a place that's taking an empty string for a resource that hasn't been reconciled yet, and it's turning it into a formatted date, which fails. So I don't know how to fix that. Maybe some enterprising person can, but we might actually see it here today. I don't think we will. So the UI works up to this point, and then when you click down here, if one of the things hasn't been reconciled ever, I think it's okay if it's gone to not reconcile, but if it hasn't been reconciled ever, then you won't be able to pull up all the Flux sources and customizations and whatnot. And this is a nice, simple UI. If I had remembered to suspend everything before we brought the cluster up, we could have stepped through here. And if you're watching this later, I will, of course, make that commit and push it. So when you fork the repo later, everything will be suspended, and you can pull up the UI and reconcile or resume. Actually, you'll want to click resume here instead of suspend. So all of these things can be suspended. These are Helm releases. And that just stops them from reconciling. It doesn't take anything down. All of these things continue to sit on the cluster. But the cluster will no longer, especially if we take this Flux system out, will no longer reconcile over us. So if you've never heard of GitOps before, open GitOps.dev has the really easy explainer where you can see what I'm talking about. So it's pulled automatically, but it's also continuously reconciled. So when we suspend a resource, we're stopping the continuous reconciling. That's what we're doing. So continuous reconciling is the thing that reverts drift. So I started to say earlier, people think that Flux needs to manage every single thing on the cluster. Well, if Flux hasn't been responsible for putting a thing on the cluster, Flux is not going to delete that thing. It's certainly not going to delete that thing. That would be a disaster. And Flux actually won't delete anything unless you enable it. This setting is called prune. So normally the default configuration of Flux is just to apply stuff. And then if you delete all of your Flux resources, hey, congratulations, that stuff is still applied. But if you enable prune, which we do recommend in that demo that I linked at the very beginning, the Flux 2 Helm customize example, prune will garbage collect resources when you delete them from Git. And that is the way that we expect most people to want to manage their resources, that if the resource is not in Git anymore, it means we don't want it applied to the cluster, and it should be deleted. Mm-hmm. So we can see in the UI here, all of these things have been paused, and you can use this UI. This is the GitOps tools for Flux. If you want to see the nice version of the UI and you're willing to install October VS Code from last year to do it, you can run 0.26.0 and you'll get all the nice features here. I'm actually hoping we can recruit another TypeScript person who wants to work on this. We sort of have the will to do another release collectively, but we don't really have a strong incentive. But if there was someone who was really excited about working on this again, we could even rebrand the thing. It's MPL. So if we want to publish this outside of Weaveworks, we technically have to rebrand the thing, I think is the way the licensing works. But
yeah, and any folks in the audience interested in contributing, let us know.
But if you try the latest version, you're going to have to click this refresh button. And that really was an important target for us to fix, because the bigger your cluster gets, the more expensive it is to do that refresh. And some of these things tree out into a bunch of different resources. So it has to inspect all those resources in order to populate the tree. So it's very expensive, and it's much better to run in the Watcher model. Is there a NeoVim plugin for GitOps? I actually have no idea the answer to that. I've only started to use NeoVim.
Yeah. What are folks' thoughts on NeoVim? I haven't used it myself. I'm still on VS Code. Any fans here?
I know there's a K9s plugin.
Okay.
So if you use K9s, K9s, that's why it's called K9s.
Who let the pods out? I like that. Oh, okay. Hey, Bunny's here as well. Bunny also is a big fan of NeoVim. Awesome. Very cool. Maybe I should try it out.
So I don't know a lot about SpinKube. I've only started to use it. There is one more app here, actually, that we haven't looked at. I started to build a little website to deploy using SpinKube. And I think we're going to see it's actually in crash loop back off. This is kind of a bummer. So we're going to try to fix it. I have low expectations that we're going to be able to fix it, but we can see how it works at least. Spin Flux docs. So this is another repo in the Kingdon CI org, Flux docs. And ooh, there's a whole bunch of stuff in there. What you want to see is actually we've built the entire Flux website in here. So there's a build directory, public, and then if you scroll way back, you can see we're just going to delete all that because it's procedural and we can generate it again. So, right, this make file has clone, just takes a clone of the Flux website. And it does that in CI as well. So we're actually not going to do that locally. We're just going to do it in CI. And what else is in here is, so there's two skills that I kind of wanted to share. One is the Bootstrap that we've seen already, and we've seen the power of that. It can bring back a big complex web of dependencies in order so they just work. And that's really the sneaky reason why it wasn't paused, is because it looks much better if we just see it all work. And if you have to unpause every single thing, you don't get that effect. So normally, and you normally wouldn't have it paused, right? In your infrastructure, you wouldn't want things to be paused. You want it to be continuous. That's what continuous integration is for. So we have a few things in here. We have a directory called Customize Flux. And this is the directory that if you want to run Flux install, forget about that Bootstrap stuff, and you just want to throw something on the cluster and let Flux manage that, this is the directory to kubectl apply -k. It's just going to take a couple of Flux resources. In fact, for effect, what we're going to do now is we're going to do exactly that, so we can see a little bit less in the UI. We're going to uninstall everything Flux. We're going to use Flux install again, which just puts it back, but not connecting Git. So this is like kubectl apply Flux, if such a thing. It just puts Flux on the cluster. It doesn't arrange this Bootstrap where Git is the single source of truth. So there's no longer a single source of truth on the cluster, and all of the Flux system resources that we saw before won't be a part of, oh, and actually this is going to fail. I think I just hosed everything because I forgot. Well, maybe not. The namespace takes a minute to terminate. So that command would have failed, but it looks like the namespace has terminated now, and we should be able to run Flux install. So this doesn't set up any deploy key. It doesn't set up any sync to the Tuesday spin demo repo. There is actually a hook in there that deployed this customize directory. And let's open this in VS Code as well.
Also quickly, just a FYI to Bunny, for some reason YouTube comments doesn't, they hide messages which have URLs. So if you sent like a URL in the chat message, it probably won't show up. So you might have to mask it with the DOT, whatever. And yeah. But yeah, if you can share that link, that would be great. Bunny had shared a link about, trying out NeoVim or trying out modal editing, if anyone is going to. So yeah.
Cool. I'm a Vim user, definitely. But I haven't really gotten into NeoVim yet. I'm excited to try, but I haven't really got there yet. So I will say one more thing about receivers, because there's obviously a trade-off. And when you want to set up a receiver, that means you have to go and set up a webhook in the GitHub UI. Or if you have a way to do that with Terraform. Obviously, that's a bit of an investment. So I try to figure out where is a good place to tell people to draw the line. Should I install a receiver for my repo or not? And I think the right place is, do we have people actively developing this thing? Because if it's software from outside, if it's software that you get from a vendor, really every 10 minutes or even once an hour or once a day is probably often enough to check for a new version. We don't really need to look for a new version every minute, right? They're not putting them out multiple times a day in most cases. Yeah. And we don't need them installed that rapidly. It would be amazing if we could get them installed within a day in most places, I think. as stuff comes down from the vendor. And one of the things I haven't pointed out here is actually, I should go back and look at the deployment for Spin. So in our apps folder, this is the structure that was in that repo. In our apps folder, we only have a very limited amount of stuff here. We have a Spin app, which is the scaffolding over our Spin app here. This is, and we also have, in our other one, we have a reference to an outside repo. So this is the Flux docs repo and how you apply it. So you can kubectl apply these things. Oops. Or you can just kubectl apply -k this directory, which is what we're going to do now. And we see that creates a few different customizations to be applied in order, and ingress to be separate in case the ingress fails so it doesn't take down the app, and an OCI repository as the source. So we're not using Git as a source here. We're using OCI, which requires some investment in CI in order to make that work. So we'll look at the GitHub workflow that does this deployment. And it's got a bunch of not containerized stuff, which I find is the easiest way to set up CI. If you want your CI to run in a container, you're going to immediately start fighting with caches. And for me, it's much easier. So what this build does, our website is in Hugo. So we're downloading Hugo at a particular version that we need with the extended bit that makes it, I don't know, it does extra things. Something important that our website build will break without. This is actually for fluxcd.io. I'm not saying that we're hosting fluxcd.io from Spin, but I'm rehosting it, or I'm attempting to rehost it here. And actually, if you go to this website, you can see it does run, or it did run on Fermyon Cloud. We can do a deployment there. I'm afraid this is not going to work when we do this here, but we're going to try. So I'm going to put this back the way it was. So there's a action push WASM here, and that's the comment. Whoops. Push to OCI. So this is the Spin bit that does spin push OCI. I'm not sure what the command is. Actually, I haven't run it manually in quite a while. This is the replacement for all the Docker stuff. So Spin has its own way to put your Spin app in an OCI. And we're going to comment out all this Docker stuff because we want one or the other.
Spin registry push for those of y'all.
Spin registry push. Yes, thank you. So Flux is doing a similar thing too. Flux has got Flux push artifact, which we actually do manually down here. So this is a two-step process. First, we're building our WebAssembly module up above, and that's where Spin push picks up. And then down below, we're packaging up our manifests and pushing them to an OCI repo. So Flux can deploy from them with that OCI repository source that we saw. So that's how we get away with not having a Git repository. And we can do the same thing for Flux itself. Actually, the first repo, I cut this from the demo because I know we have limited time. In the first version of the demo, we were taking our Flux Bootstrap definition of Flux out of the repo since it's several thousand lines of YAML and I don't want to have that in my repo. I'm just replacing it with a reference to the Flux OCI manifests, which we can do cosign verification on. We can do fun stuff like that. So we are also signing our OCIs here. We sign our OCI YAML. And this is the step that failed. That was why I got stuck last time. So I'm using -3 as a signifier that means this is the Docker build, and -2 is the Spin manifests, I guess. I just want to make sure they line up here. Okay. So we use customize edit set image to update our manifests in the CI. And that means we don't actually have anywhere in our manifests in Git that refers to the WebAssembly module that we're building, which makes sense because we're going to build one for every commit. So that would be weirdly recursive if we had to write the module into Git. And we sign our build from Flux. Try build with spin registry push. So let's pull up that repo.
We have a couple of questions from Will, which we'll get to that in actually one question in just as soon as this is done.
So what we'd like to see is these pods get deployed over as soon as this deploy is done. And I'm not sure it's going to happen quite that fast because we haven't set up our receivers. So we're going to reconcile this as soon as we see the build is done. And then we should see there's a lot less stuff in here now. It's a lot easier to work like this. So there is an argument for not doing full GitOps Bootstrap everywhere. I think on dev clusters, it might make sense to use a style like this, where you just have a customized directory, you apply from there, and you get the whole works, whatever is meant to be bundled together.
While that's happening, Kingdon, we have a question from Will, which is, do you have any words of wisdom to help people adopt using Flux with Spin on Kubernetes?
Yes. I read the Cozy Stack docs. I think it was the Cozy Stack docs. And I thought the way that they laid it out was very good. Oh, no, it was different docs, actually. Someone from New Zealand, I think Blue Penguin something?
Oh, yeah. People, yeah, Ivan from Fermion, which is...
Bluish Coder is who I'm thinking of, I think. Maybe not. No. Someone... laid it out really well about Flux, is that it's really a 3-step process. Deploy and then understand comes later. Like just get it installed. If you're one of those people that tries to read the docs from cover to cover, you're going to confuse yourself. Flux is very easy to use. And we get messages from people all the time saying things like, I have no idea how to upgrade Flux. I'm using an old version of Flux. And I don't want to say just try because I know a lot of people have production situations and they can't just try. If it fails, there might be repercussions. But you should have a staging area. That's my second advice. If you don't have a staging area that has a reasonable amount of replication of all the complexity of your production environment, then you're setting yourself up for failure. Okay, so it looks like we did deploy an OCI. We did push, and this worked a few weeks ago when I tried it. I was really looking forward to show everyone the Flux website hosted on Spin. But there are a couple of things. I think what happened here is I was using a newer version of the containerd shim when I was using Talus extensions. I think KWASM operator isn't updating anymore at the same pace as the containerd shim. So I think that's actually what got me. But it didn't air out. Does that mean our pods are ready? This might be another, this is another bug here. Is that Flux normally tries to keep track of the readiness of things so that it can tell you if it was a successful deployment or not. But if we look at the Spin app here, it says ready 0. I don't know how Flux is interpreting this as ready. I talked to some of the devs and they told me we're just copying the status from the deployment. So this doesn't look ready to me. I'm not sure how it's getting interpreted as ready, but that's a bug for Flux to resolve, or SpinKube, I'm not sure which. But we'll try one more thing here. We're going to deploy this actually to, where is the deploy here? Deploy to Fermion Cloud. So this was originally in as an earlier step. What we had to do to make this work in OCI was to remove a bunch of the content, because I think each of these bits of content gets packed in an individual layer, ideally. so they can be cached independently. But when you have hundreds and hundreds of files, it doesn't work. So this is going to be a slimmed down version of the Flux website.
Okay. Kingdon, Will's asking if the readiness probes and the liveliness probes are getting confused, and hence the state is different.
I don't know, because I've looked at another resource. I looked at OpenFunction recently, and they claim to be doing the exact same thing, but theirs works. So I'm not really sure how it gets confused, because it looks to me like they're doing. I was a little mystified by how the deployment works, because it doesn't read like a regular K status to me, but it's deployment, so it's got to be relatively canonical as the way that things should work. I think that there should be a ready status or ready reason, and that's the easiest thing to parse, because if the ready reason is present, it's either true or false, and there's not any fall through logic to do. But if you read the way case status is written, it's actually really specific that you don't need to have a ready status there, and so I breaks down a little bit in my head when I try to understand how should that work. By the way, I maintain the Flux website, so if you're worried the Flux maintainer doesn't know ins and outs of how controller runtime works, just back off a little bit. I'm doing my best. I'm trying to learn here. So yes, I was a code maintainer for Flux v1. When I came on, the action item for Flux v1 was don't change anything, because it's already v1, and it has to remain backwards compatible. So all the nice things that people want, all the PRs that they submit for things that are going to break Flux, you need to let those people down gently. That was my mandate. Tell them to get on Flux v2. That's where the action is happening. That's why Flux v2 was in pre-release for so long. It went through 42 minor versions before it was declared Flux v2.0.0. So I think we're past the deploy step here now. And this might be a good advertisement for Fermyon Cloud here, because this, honestly, I never had problems with this. I didn't have to remove any content to make deploy to Fermyon Cloud work. It worked great right out of the box with this approach. So I had a good experience trying to develop on Fermyon Cloud. I think SpinKube still needs a bit of work, and that is acknowledged by the pre-release version. Everyone who looks at that should understand and know these are still work in progress at some level. But I think you probably have advertised the Fermyon community plenty on here, so I'll do a little plug for the Flux community. We have lots of meetings. And this calendar should be localized in your time zone here. So this is hosted on Fermyon Cloud.
Sweet. That's pretty cool. Yeah, and thanks for the shout out for Fermyon Cloud. I think if Peter is around watching the stream, Peter, do check it out as well. You were talking about the Fermyon Cloud. But also, I think we have maybe a few more minutes, Kingdon, and you wanted to show us like a architecture diagram. So that would be cool. So let's do it.
Yeah. About how my home network is built. Let me see. Yes. Where did it go?
And in the meanwhile, I will post the link for the Flux CD community so that if folks want to get involved, you can. I also see you have a bug scrub coming up, which is pretty cool.
Right. Yeah, we bug scrub. We do once a week. I say once a week because it simplifies things, because 2 bug scrubs do happen in the same week sometimes, but they're on alternating time zones. So you probably wouldn't want to go to both. No. But they're sort of like one long 12-hour event that we just go to sleep in the middle of. So there's bug scrub AEST if you're in Australia. That's hosted by a community member, and I join. Bug scrub is a place you can go to talk to a Flux maintainer. Basically, it's a low-key version of the dev meeting that's not usually recorded. And we talk about stuff like this. So here's the architecture that I've been working on for a while. You see there's old cluster and new cluster. I mentioned that the old cluster provides some services that we need. They're from this pool of IP address load balancers. Like there are things like databases on here, and there's a Deis workflow instance. Shout out to Deis workflow. It's Happy workflow now. I don't know, I didn't mention this earlier, but if you've ever heard of Deis workflow, if you know who Deis is, Fermyon folks, a lot of folks at Fermyon came from Deis before they were at Microsoft. And they built this great thing called Deis workflow that was open source. And we forked it and kept it up after they left to some extent. It's kind of a little bit in shambles now because you can't really install it on the latest Kubernetes because it depends on Docker so explicitly. We haven't really changed much about it. So that stuff all sort of stopped working on Kubernetes 1.23 when they hard cut over from Docker to Containerd. But if you're using Slug Builder, that stuff still works. We have a report from at least one person who's still using Happy Workflow, and they don't use Docker build at all. They don't use the Docker registry. So for them, it just still works. WeaveNet is another one of those things that's got a maintainer now, actually. WeaveNet was probably most people's first introduction to Weaveworks. And there is a maintainer for WeaveNet who's from Bangalore. His name's Raj.
Nice.
Yeah.
Bangalore's a city I grew up in also. So yeah, shout out Raj, I guess. Nice. Very cool.
So there's a lot of services that I'm trying to move one at a time over here. And I figured I really needed to make an architecture diagram first so that I would feel a little bit more free to just delete stuff that I don't need, because a lot of this is just leftover demo stuff that, you know, I needed a database for this one demo. So there is the database and it's still running. But there's a line across where the VLANs are set up. I did this a few weeks ago. So there's 24 port switch over here with 3 banks of 8, and VLAN 3 is the new, the old network, and VLAN 2 is the new network. So I did this so that I could do TFTP booting, which I wasn't really comfortable with doing on the switch that normal computers plug into, because they might get reformatted and wiped at any time, and I would feel really bad if that happened to my wife's computer or anything like. So I set up VLANs. Hopefully the config never gets wiped from the switch. I don't think most computers will just net boot randomly. I think they have to be configured for that, but it's a risk anyway. I'm always thinking of mitigating the risks. And so the difference is this one bootstraps Flux at the top level, and it creates vClusters that are nested in each other. So there's a vCluster that also hosts vCluster workloads. I really like vCluster. I want to catch up on what they're doing now with the latest version. I haven't quite got there yet. There was a while the cluster API provider vCluster wasn't really being maintained, and you just had to use the Helm chart, which kind of broke my spirits a little bit, but they've come back and decided they are going to maintain it. So that's really good. This is an important thing for the community, I think. And what I want to do now is I want to have my virtual clusters. I want to put vClusters inside them. So the Kamaji KubeVirt clusters that come from Cozy Stack will also host vClusters, I think. And this is an important scaling tool because I realized with my 2-node cluster here, I'm still 2 nodes, no matter how many vClusters I get. So when I start to hit per node pod limits, I'm going to get those, but scaled across all of my vClusters. So this strategy is a lot better because when we start to come up against pending pod, anything like that, it just creates a new virtual machine on the fly. It watches, and there's an API provider, something that's monitoring for pending pods, and it scales up the number of virtual machines as needed. So as long as there's still capacity on the cluster, which there is, both of these machines, all 4 of these machines are just loaded to the gill with RAM, then we should be able to create more virtual machines and just let them get slower, subtly slower.
Awesome. Yeah, I'll be honest, some of the networking stuff went way above my head because not really my wheelhouse, but very cool that you can build this. For folks who watched, I think just again, like a big chunk of the demo, especially the one that Kingdon showed earlier in the stream, is here at github.com/kingdon-ci/spinflux Tuesday demo. So check it out. You can watch the stream again. There is that one part where from there you could, put it onto your own Kubernetes cluster and play around with it as well. We've come to the end of time, Kingdon. Anything else you quickly want to share, words of wisdom, before we wrap up?
I think that's it from me. Reproduce all this Cozy Stack stuff at your own risk. I think it's really cool. But I don't want anyone to think that this is production ready. There's definitely warnings in the README. But please try and fork the repo and bootstrap it. If you want to try SpinKube, definitely give it a shot.
Yeah, well, thank you so much, Kingdon, for jumping on the stream. Definitely one of the geekier streams that we've had, because we did so much cool tech stuff. And thanks to everyone, Peter, Will, Nerdy, Sean, Bunny, everyone else for joining in. Will says, thank you, excellent demo. Yes, I echo that, Will. That was an excellent demo indeed. Folks, next week we are joined, who's joining us? Oh, Sebastian Blanc from Avon is joining us. So he built like this AI chatbot using Spin, but it also uses Redis on Avon for, like some memory stuff. So he'll be teaching us that as well. Thanks again, everyone. And we'll see you next week, same time, same place, and have a good rest of the week. Bye-bye.